Hello again, and welcome back to part 2 of the Topic Speed video for OrCAD X. My name is Adam, and in this video, we'll look at how to actually analyze the signals which we have extracted from our OrCAD X layout. Now, in the previous video, you might remember that we assigned some models to different devices on our board, and then we looked at a singular net in our design and extracted it into this topology workbench. So the first thing that we could do is actually click on each of U2 and U20. And in the properties panel here, we can see what the IBIS file is that is assigned to each model. Simply clicking on this, we can see the model name as well as the signal name. And if we were to make any changes, we can do so through here. The next thing we need to do in our topology workbench is to follow the workflow that is shown on the left side. And we're not working with any libraries here. We're just setting up an extraction for a single signal. Next thing we need to do is to check our connectivity. So this will bring up the connectivity checker panel on the bottom, and then we can go ahead and click check. And it's going to tell us that there's actually an issue here where both of the IBIS blocks, which is U2.E3 or U2 pin 3 and U20 pin A9, are actually receivers, and so one of these should be set as a transmitter. It asks us if we still want to continue the simulation. I'm going to go ahead and say no. What we actually want to do is click on this U2.E3 block. Let's go ahead and make it a transmitter. Again, in this properties panel, there's this type section here. Let's go ahead and use this drop down and set it to transmitter. You can see in the graphic here, we have a TX, and here the graphic we now have an RX. Again, since our connectivity checker is still open, we can go ahead and click check again, and we are good to go. So once everything passes, again, using the workflow on the left, let's do our next step, which is to set the analysis options. Now, in the analysis options, I'll just make this a little bigger. You can see that we can view the circuit simulation options, as well as the different IO models and stimulus that we are applying. Again, most of these steps are just to ensure that everything is set up correctly, especially if you're running with a much larger simulation. Maybe you have a lot more signals that you're dealing with. The only thing that we need to change here is if we look at U2 pin E3, we have the data rate set to 1 gigabit per second. But we actually want to change this number of bits to, let's say, 128, just to make sure that we have a much larger waveform to look at once we run our simulation. And once this is done, we can start the transient analysis and view our results. If we needed to, before running the analysis, you can also save this topology if this is something that you want to rerun in the future. But we'll go down here to start transient analysis, and let's see what we get. Awesome. So once the simulation is complete, we get, a time domain waveform. And these are displayed in this 2D curves tab at the top. If you need to go back to your topology, you can always go back here, maybe make some adjustments to your analysis options or any of the IBIS models that are assigned in your topology. On the left side here in the curves, you can enable or disable different curves from your plot. You can also change the color. Click OK. And in this case, I just want to enable our transmitter signal and also the signal as it is in the receiver, except in this case, maybe choose a color that stands out a little more. There we go. Using the options at the top left, we can, for example, scale our graph. We can use the navigator or even the area mode to zoom in on a section of our signal, like that, in order to get a better close-up view of how our signal propagates through our topology. And at the time, there are also some additional options. For example, you can use this drop-down to look at your signal in the frequency domain. You can view the waveform, the eye contour, etc., as well as this very commonly used option, which is to just show the eye diagram. And here you can see the eye diagram for the signal, which we have analyzed. So that's about it. If you are looking to simulate and extract a topology, the Topology Workbench has all the tools that you would need to do that. Hopefully you guys enjoyed this video. And if you have any questions or comments, please leave them below and we'll try to get back to you as soon as possible. If you have any recommendations for what you would like to see in a future video, please let us know as well. And again, thank you for watching, and I will see you in the next video.